Okay, for example, 5, you'll notice that he has a constant. That means if it's positive C, it's going to go up. If it's a negative C, it goes down. The A is the amplitude. If A is, in his A, if A is positive, that means it's not reflected over the x-axis. But if A is less than 0, you're going to see that the sine curve will flip and be upside down. Or the cosine curve, which normally look like that, will look like that. And then inside you have, he's calling it the B that we factored out of a set of parentheses here that has an X in the front, no number in front of the X. That just tells you that 2 pi divided by that B will tell you how long it takes for a cycle to be done. Now, of course, this minus D is what tells us if we're going left or right. Basically, if D is positive, then it's a minus D, and a minus D would imply going to the right. If D was negative, that ends up with a plus D. Since D is negative, we are going left. Now, let me clear those notes off. And I also want to make one note. You know, it's hard to teach an old dog new tricks. So I'm used to writing it out like this. Y equals, I like to put my amplitude in the front, and then I'll put sine, or it could be cosine. Then I like to keep that B factored out, so I like to put the B on the outside of the parenthesis, and I notice you could say it's a parenthesis as well. And then I do after B is X minus C, where he has a D. It's just because I'm doing it in alphabetical order. A, B, C, close that off. Then I do my plus D, plus or minus D, whatever I'm doing, plus or minus D. So I switched a couple of the letters around just because that's basically helps me say amplitude, my the period, okay, is developed by looking here to see how many complete cycles are done in 2 pi, how many. So this determines the frequency, okay. The period is how long does it take to finish one cycle. And then my D is my up or down. So I'm looking at this problem. The thing he does different, he puts this constant in the front, which it makes no difference where my D goes. But I notice his book does this a lot. So he wants 2 periods, so it doesn't really matter where you put your 0. You really don't even care where 0 is. If he wants 2 periods, you could if this is your 0, you could literally do a period to the left, and you could do a period to the right. If you wanted to, that's still 2 periods. I don't know what the textbook technically does. I'm not too concerned, to be totally honest with you. There is a possibility that he wants you to go to both sides. Or you could just say, no, I'll do a period going this way, and I'll do another period to the right. There's really no right or wrong answer. He's not telling you necessarily which 2 periods to do. So if I want to call that 0, then I'll try to work around that. Let's see. this minus 1 means the whole thing shifts down. So instead of calling this a 0, which normally this is the y is 0, why don't I call this the y value of a negative 1? Then, if my amplitude is 2, the negative 1 plus 2, if I add 2 to it, then this horizontal line would become a negative 1, a 0, and a 1, down to negative 2, negative 3. So I got my other one down here at a negative 3. These numbers are very important. The 1, the negative 1, the negative 3 are very important. Next thing I'm going to look at. He did not factor out the b. So I should rewrite this problem. Y equals, he wants to put the negative 1 in front, that's fine, plus 2 sine, factor out the 4. So when I factor out the 4, then this becomes an x plus the pi over 4. Because pi over 4 times 4 is just the pi that I had to begin with. So now that I've factored that out, I need to ask myself, the period will be 2 pi divided by my b. So this is 2 pi divided by 4. A whole cycle is done in pi over 2. A whole cycle is done in pi over 2. So that's important to know. That's the number of radians. That's actually 90 degrees. Every 90 degrees, this picture is done over again. So, which is kind of scary because normally it takes 360 degrees for one cycle. We're going to complete the whole thing in 90 degrees. That means between 0 and 2 pi. If I call this 2 pi, I literally could get, this would be my pi. And so I'm only doing one cycle right now because I used that whole part up. I said pi to 2 pi. If you wanted to do the whole cycle, then what's going to happen is that would be the normal sine curve would have done this. I think I got it. I got to go down. Well, I should practice what I preached. If that's 0 to 2 pi, then I should have 4 spots in between. So let me get rid of that. Let me get rid of what I was going to graph. So start here, goes up here, comes back down here, comes down here, goes. That would be the normal curve going to 0 to 2 pi. But this one finishes in pi over 2. And also, this one does not start at 0 like this one did. So I said all that to say to you, what I do is I try to just say, if I want 2 cycles, I think this time I'll be a rebel and I'll do 1 on each side. No, I'll do 4. Actually, I'll end up doing a lot of cycles. Let me go, and this is not going to be a pi no more. Okay. All right, and so here's going to be a cycle. Here's going to be a cycle. Oh, by the way, this won't be 0 anymore either. So let me erase the 0. The horizontal lines don't change. It's still up there at a 1 and a negative 1 and a negative 3. That doesn't change. I just want to fix this one. So if this is going to be one cycle, where does it start? It starts at, that's a plus pi over 4. So that means it's starting as a negative pi over 4. That's where it starts. Okay? And since it takes pi over 2 to get to the end of it, I have to take the starting place, negative pi over 4, and add pi over 2. I know you love the fraction work. I know you love it. I shouldn't put that number up there. I should put it down here. Negative pi over 4. This is actually the x value. This is where it starts, okay? And it's going to finish up here, whatever this number is. And since it's going to start here at this line and end at this line, let me divide this up into 4 equal pieces. So the picture looks like this. It starts at where I would consider 0, 0, but it's not really 0, 0 because it shifted down. But it's still going to go up to the highest place. It's still going to cut through back here and come back down here. And there. So it's going to look like this. That's the picture. Oh, and I may as well finish up another 2 cycles. Look at it. It's got to start here. It's got to go up to here. It's got to come back down here. It's got to go down to here. It's got to go to here. There's 2 cycles starting at negative pi over 4. So if it starts at negative pi over 4, and I got to add pi over 2 to it to get to the end, because that's what my period was. I'm sorry, that's my period. The frequency is 4, means within 2 pi, I'll get 4 of them done. And I'll show you what I mean by that. In 2 pi, well, maybe I won't. Add that up. My system is take this 2 times the negative pi, that's negative 2 pi, plus the 4 times the pi. All divided by 4 times 2 is 8. That turns into a 2 pi divided by 8. That means it's finishing up in pi over 4. Positive pi over 4. Well, that makes sense because a negative pi over 4 would be a negative 45 degrees. The negative 45 plus 45 is 90 degrees, and the whole thing does finish in 90 degrees, if you recall, pi over 2. So that makes sense. So now that I've done that, I can fill in some more numbers. That's the beginning and the end of one cycle. In the middle would have been a 0. My 0 goes there because negative pi over 2, let me show you here. If I want to find the middle between 2 numbers, I take negative pi over 4, and I add it to the pi over 4, and then I divide that number by 2. That 0 over 2 is 0. That's how I knew that. Let me go ahead and get this tick mark here. What does it become? To get the middle between negative pi over 4 and 0, I take negative pi over 4, I add it to the 0, divide by 2. That's a negative pi over 4 divided by 2. That means the bottom number just gets doubled. That means a negative pi over 8. So this number should be negative because to the left of 0 is negative pi over 8. This number between 0 and pi over 4, if you add them together, I get pi over 4 divided by 2 is a positive pi over 8. There's one complete cycle. I'll do one more cycle. Here goes. I'm going to use this cycle here. It starts at pi over 4, and pi over 4 plus the pi over 2, the time it takes to finish up, would be 2 pi plus 4 pi over 8, which is 6 pi over 8, which is 3 pi over 4. So what did that imply? That meant it finishes up here at pi over, was that correct? 2 pi plus 4 pi is 6 pi, no, I'm sorry, 3 pi over 4. 3 pi over 4 is where it ends. Okay, let me make that smaller because 3 pi over 4 is where it ends. And the beginning of this was pi over 4. So now I can finish up. What's the middle? That's the easiest one to get. What's the middle? You take pi over 4, add it to 3 pi over 4, divide that by 2. Look at all the scratch work. Normally you'd put that scratch work somewhere on the side of a paper, and that way you get a pretty graph. I'll try to do better on the next one here. 3 pi over 4 plus pi over 4 is 4 pi over 4. Divide that divide by 2 turns into really a pi, because those cancel out, pi over 2. So right here, pi over 2. To get the next middle number, I'll do it in blue here. To get this number right here, I have to take the pi over 2, which, wrong one. Pi over 2, which is that, add it to the pi over 4, divide that by 2. That turns into 4 pi plus 2 pi is 6 pi over the product 8 divided by 2. You could also treat this as 6 pi over 16, because that's what happens when you take a fraction divided by a whole number. That's really flipped of a 1/2. So anyway, you could have also reduced right here. You could have said 3 over 4. But either way, I can reduce now. 6 pi over 16 is 3 pi over 8. So that middle number here is 3 pi over 8. Do the last one here to make it a full 2 complete cycles, labeling everything. And I'm running out of, I have virtual space, but I'm running out of room close to it. So here goes. Between pi over 2 and 3 pi over 4, I add those together and divide that by 2 to get the average. That gives you the middle. So that gives you, my shortcut is 4 pi plus 6 pi is 10 pi over 8, but I'm going to double that over 16. 5 pi over 8. So there's 5 pi over 8 right here. 5 pi over 8. Now that's if you want to label all the numbers, and that actually is the best way. For fun, let's just go the other way around. Let's go backwards. I want to make another cycle. So this cycle would be 4 tick marks, but it's going this way, so it's going to down and hit the minimum. It's going to go in the middle again. Then it's going to hit the maximum. Then it's going to be down here again. So look what it looks like. It looks the same, right? And to find those numbers, I'll put my scratch work over here to be clear. How do I find the first number here? How do I find that? Then I got to find the middle of those two. Then I got to find that number. Then I got to find that number. I already have the end of it. So I just need to get these 4 numbers. That lines up with this one, this lines up with that one, this lines up with that one up here, and this lines up, well, those are the important ones. So what I'm going to do is, if the cycle is pi over 2, this distance here is still a pi over 2 distance, but this is a negative pi over 4. I'm going left, so watch this. Negative pi over 4 minus the pi over 2, since I'm going left. That's all you do is when you find out where does it begin and end, it's the difference of pi over 2. That turns into a negative 2 pi plus 4 pi. I know, how am I doing that? I put the negative on the pi instead of here. 2 times negative pi is negative 2 pi. Minus 4 times pi, or 4 times, I probably messed up here, it should have been a minus. Let me do it again. It's a lot. So easy to, okay, I'm adding a negative pi over 4, and I'm subtracting a pi over 2. Okay, we know the answer's got to be negative because we're going left. So it's a negative 2 pi minus 4 pi, yeah, that's what I did wrong, over 8. That turns into a negative 6 pi over 8. That's a negative 3 pi over 4. So found one. This one is negative 3 pi over 4. Now, to get the number that's in the middle, here's the one that's in the middle. I take these two numbers, I add them up and divide by 2. So I'm going to go negative 3 pi over 4. I'm going to add it to a negative pi over 4, wasn't it? Yes. Take that answer and divide by 2 will give me the midpoint that I was looking for right here, okay? The x value, the angle. That turns into a negative 12 pi minus 4 pi divided by, oh wait a minute, that was kind of silly. They both got the same denominator. It'd have been easier, I didn't realize they had the same denominator. I could still keep going the way I was, but if you don't have to, why do it? Negative 3 minus 4 is a negative 4 pi over 4. But when you divide it by 2, it becomes a negative 4 pi over 8, which turns into negative pi over 2. Negative pi over 2. Okay? Now to get this middle one, this one right here, I need these two added together and divided by 2. So I'm going to keep doing my scratch work over there. So I need to take my negative 3 pi over 4 and add it to a negative pi over 2. Negative pi over 2, add it to a negative 3 pi over 4. Take that answer divided by 2. That turns into a negative 4 pi minus 6 pi over 8, because that's the product of those two. But I'm doubling it, so it's really over 16. So that's negative 10 pi over 16. That's a negative 5 pi over 8. So I go over here and I write negative 5 pi over 8. One more and I'm home free. Between the negative pi over 2 and the negative pi over 4 will give me this middle number. Here it goes. Negative pi over 2, negative pi over 4. I'm adding up two negative numbers, taking that, dividing it by 2. Since they're both negative, let's see, that's going to be negative 4 pi minus 2 pi over 8, which is really over 16. Negative 6 pi over 16, negative 3 pi over 8. That one is a, last one, negative, where am I at? Negative 3 pi over 8. All right. Was there another problem on this page? The good reflection, describe the effects of the parameters A, B, C, and D on the graph of the model. All right, using his letters, not my letters, because I already told you I like to use A, B, C, and D. But anyway, we know C is up or down, depending on if C is less than 0 or C is greater than 0. A is the amplitude, so that basically tells you the absolute value of A, tells you how high and at the same time how low will it go. And interesting thing about those two numbers, if you know where those numbers are, that middle is actually the same value as C. That's important. B tells you the number, that's the frequency, call it the frequency. Number of complete curves in 2 pi. And last but not least, he's calling D. D tells you if it's left or right. Okay, so if D is greater than 0, then you're going to the right. Because all you do is get is a minus a positive D. That turns into minus, so that means you go to the right. D by itself less than 0 makes it a minus minus. Therefore, it will go to the left, okay? And the trigonometric model, like everything else, if you have data, and this person keyed all this data in their calculator, they had to have at least numbered these somehow. Let's see how they did it. The maximum average monthly temperatures in New Orleans is 83 degrees Fahrenheit, and the minimum was 53 degrees. So obviously, you got your lowest that this thing is going, and it looks to me like he's graphed a couple of cosine curves. When you think about it, look like a couple of cosine curves. So the highest was the 85, and the lowest it could have gotten would be the 53. So I'm just guessing here, 85 up here and 53 down here. In the scatter diagram for a 2-year, there you go, see, 2 years, that's why there's two cosines, suggests the temperature can be modeled by a sine curve. Well, everything can be modeled by a sine curve. I mean, it doesn't really matter. It depends on where you want to start. For instance, if you go to the middle of these two here, let me go to the middle. That's what I didn't do a second ago. If I go to the middle of this thing, yeah, then they can see how you could actually see how you could start a sine curve starting here. You could go up, and then there's a sine curve, see? Or you could start here and do a negative sine curve here. See, there's a lot of things you can do. Let's see what he has done. He put all the data in a calculator and he plotted these points. I'm assuming he numbered the months, like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So when you graph those points, 1 comma 53, 2 comma 56, dot, 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 all the way till December 12 comma 55, and he did a plot. He got these dots. Let's assume it's already done. Using only the max and min temperatures, determine a function of the form. So he wants me to create a sine curve using the pictures that are up here that models the average. And he does say, look at x equals to 1 was January. So I was right on that. And let's see if he says sine curve, but I still don't like the fact of saying a sine curve. The good news about it is I don't have to start. I can start anywhere I want. So I'm going to start right here, because that makes a beautiful regular sine curve. So I need to find out some numbers. My amplitude. My amplitude has to be the distance from the middle. So the easiest thing is to take the distance here, 85 minus 53. That's a total of 2, and if somebody was here, 32. Okay, so that whole distance is 32. So half of that is 16. So what that tells me is I know this must be 16. And I know my amplitude must be, no, that's my amplitude, 16. I took half of that distance. 16, that's what I'm gonna do. My amplitude is 16. Let me get rid of that, the evidence here. I got it, the middle, I wanna erase again because I didn't do this. The middle number, so if this top is 85, then to get this dotted line, which is my, that'd be this number right here. Well, I want it right now. It doesn't write what I want to write. That is my C right here, that dotted line here. So let's take that 16. If this distance is 16 right here, I'll take 85 just minus the 16. That'll be my C number, okay? So 85 minus 16, that's 9, and that's going to be minus 2 is 6, 69. Is that right? And then let's check it out. 69 minus 16 would be 53, and that was the lowest? Yes, okay. So 69 is my C number. So C is, let's say 69. That's what I said. What else? Okay, so B stands for how many cycles would be in 2 pi. Now, from here to here is where it, not here, from here to here is where it finished up. It looks to me like if I add this much distance added to what's left over, that means you've got two different sine curves in there, or cosine curve, however you want to look at it. I'm going to go with, and I might want to double check with a calculator when I'm all done to see if it looks like that. I'm going to go with my B. The number of cycles is a 2. That's the number of complete pictures that are in there. Even if I choose the cosine and shift it over here, 1 cosine, 2 cosine, if I call that whole period 2 pi, that would make my C, I already did the C. What am I missing? My D. Okay, that's the hard part here. Before I do D, I noticed I read my number wrong here. This is an 80, no, it's not an 85. It was an 83. That's a 50. 83 minus 53, not 85. And so that is, what's 83 minus 53? I did, so I got to do that. 83 is not 32, it'd be 30. Then half of 30 is 15. Okay, so that changes my, if that's 30, if this distance is 30, then half of that is 15. So that's going to change that. And then 30 plus, the C will change then. Okay, the C is going to change. How much will the C change? What did I have? I had 69. It'd be 68. If I did my math over here somewhere. Or did I get, oh yeah, see, it was an 83 minus the 15. I think that's going to be 83 minus the 15. Yeah, try that out. 68. All right. Now we still got to deal with that pesky D. While I'm being technical here, I was talking about this being like a 2 pi, is being done twice, but really every 12 months, the whole thing's going to repeat. Figure out, so whatever's happening here, next year should be about the same. So what I should do for B is think about 2 pi divided by how long it takes. 12. That would be pi over 6. I'll go with that for my B. And still got the D to worry about. And I'm starting my picture, as I said, right here. Right here. Let me erase everything and see what's my shift. Doggone it. It's not erasing again. Oh, it's not erasing. Still not erasing because I'm not on the eraser. There it is. Okay. So here's my thought. And if I drew my horizontal, and I was saying I'm starting at about here to go up and down there. There's my complete picture. Each of those dots represent a month. So out of months, it's 1, 2, 3, 4 months. 1, 2, 3, I'm shifting 4 months. And I'm shifting it, I'm going to go with 4, and I shifted it to the right. So I think I'm just going to run with is a 4. So shifting to the right means D is going to be a plane 4. So my equation should look like this. Y equals 2. Do the letters he has. A, what did I say A was going to be? 15. 15, and it's a sine curve. And I said I'm going to put pi over 6 as the number outside of the parenthesis, and x minus the 4. And then I'm going to say I'm shifting up the 68. Is that, yeah, my C was 68, so I go plus 68. And that is how you would write that out. I don't know if it's right, but close. On the same coordinate axes, graph F for a 2-year period together with the actual data values found in the table. I don't know if I want to do that. The actual data. Oh, I think what he wants me to do is graph this equation on top of the data. So he actually wants you to put that data into your calculator, do your linear, and do a stat plot, graph this and see how close it is. I'll let you do that. I don't want to type in that data, and I don't want. When I was teaching stats, we had to do a lot of these things. And then D says, well, once you type the data in, you actually have a button to do a sign regression. Then what you can do is actually tell the calculator to figure out the real equation for these dots and see how close your equation is. If anybody wants to demonstrate that, then maybe you can get extra credit. But you'll have to demonstrate these two things. Not just give me the answer, because you can get the answer somewhere. Okay. Thank you very much. That's it.